Download this code from codegive.com, link in the description below. Inference in deep learning refers to the process of using a trained model to make predictions on new, unseen data. This is a crucial step in the machine learning pipeline, as it allows you to leverage the learned patterns from your training data to gain insights or make decisions based on new information. Key concepts in inference. 1. Model training versus inference. During training, the model learns from labeled data. Inference, on the other hand, involves using the model to predict outcomes for new, unlabeled data. 2. Model deployment. Inference often occurs in a production environment where the model needs to be deployed for real-time predictions, batch processing, etc. 3. Performance metrics. It's important to evaluate the model's performance on a validation set during training, but inference also requires consideration of latency and throughput, particularly in real-time applications. 4. Pre-processing. The input data often needs to be pre-processed in the same way as during training to ensure consistency. Example tutorial: Inference with a pre-trained model. In this tutorial, we'll use a pre-trained model, for example, a convolutional neural network, for image classification. We'll use PyTorch for this example, but the concepts can be applied to other frameworks like TensorFlow or Keras. Step 1. Install required libraries. Make sure you have PyTorch and TorchVision installed. You can install them via pip if you haven't already. Step 2. Load a pre-trained model. We'll use a pre-trained ResNet model from TorchVision. Step 3. Define a pre-processing function. The input image needs to be resized, normalized, and converted to a tensor. Step 4. Perform inference. Now that we have the model and pre-processing function, we can perform inference on an image. Step 5. Run the prediction. Finally, you can test the prediction function with an image. Summary. In this tutorial, we demonstrated how to perform inference using a pre-trained deep learning model in PyTorch. The steps included loading a model, pre-processing input data, and making predictions. This process is fundamental in deploying deep learning solutions for various applications such as image classification, object detection, and more. Considerations for inference. Batch processing. In a production environment, consider processing multiple inputs in a single batch to improve throughput. Optimization. Techniques like quantization, pruning, or using optimized inference engines, example TensorRT, can help improve inference speed and reduce resource consumption. Monitoring and logging. If deploying a model in production, implement logging and monitoring to track model performance and data drift over time. Feel free to adapt this example to your specific use case, and happy coding!